So as your square matrices get larger and larger, it turns out that computing the determinant for that matrix is going to get trickier and trickier, as you might have guessed. In the 2 by 2 case, it was really easy. You can sort of take the cross sort of products there and subtract them, and you actually get the determinant. But what about for a 3 by 3? For instance, what about this matrix right here? Well, there's actually, for a 3 by 3, there's two methods. You can actually sort of adopt the previous method of sort of those diagonal things if you're careful. I'll just say this in words so you can just hear it once. But then I'll show you a way that actually can be used no matter what size the matrix is. So for the 3 by 3, what you could do is try to adopt the method used for 2 by 2. Remember, 2 by 2 was take this and then subtract it from this. Well, you can sort of do that here, but here there's a lot of diagonals, and you have to consider all of them. So let me just show you what you would do. What you would do is you would take this times this times this. You would take this diagonal of 3. But then you would actually add the other diagonals of 3 that are going in this direction. For example, this, and then you'd have to come back to this one. See, 1, 2, and then 3. That would be another diagonal of 3 in this direction. And then you'd have 0 times 1 and 3. There's another diagonal of 3 in this direction. So you'd have this diagonal of 3, this diagonal of 3, and this diagonal of 3. You would take the products of each of those three numbers individually, add them up, and then subtract from that all the diagonals of 3 in the other direction, which would be this diagonal, and this diagonal. So in fact, you can find all diagonals of 3 that go this way, so 1, 2, 3, and subtract from that 1, 2, 3. And that will work. But unfortunately, it doesn't generalize to higher and higher sizes of matrices. So let me show you a way that actually will always work, and it's sort of the divide and conquer method. That is, once you know how to find determinants of 2 by 2 matrices, let's use that fact to find determinants of larger matrices. So the first thing you have to remember is to make a little sign chart. And it's easy to make the sign chart. You just put in a sign for each position of the matrix, and you start with a plus and you alternate. So plus, minus, plus, minus, plus, minus, plus, minus, plus. So you made a little sign chart. It's always the same thing. You start with a plus and alternate as you go through. So you get sort of like a checkerboard looking type thing here. Now, here's how you find the determinant of a 3 by 3 matrix. You pick any row at all. So it could be this row or this row or this row. And that's the row that you want to sort of expand about. And what you do, let's suppose we just pick this row here to expand about. I take this number right here, 2, and I'm going to multiply it by what I would get if I remove the column and the row that contains 2. Now let's think about that. The column that contains 2 is right here. So let's get rid of that one. Whoop. Now let's get rid of the row that contains 2. That's this one. If I do that, whoop. Now look what I'm left with. I'm left with a 2 by 2 determinant. So I can actually find a 2 by 2 matrix, and I can take its determinant pretty easily. It's just, this cross thing. So I take that determinant, and I multiply it by that 2. So I take 2 times the determinant I get if I cross out the things that contain 2. So basically what I'm doing is this. I'm taking the 2, and I'm crossing out the column and the row that contains 2. I'm taking the determinant of this and multiplying it by 2. That's the first term I'm going to have in my determinant. Now, I take that and I add that because I see a plus sign here. Now I jump over to the next element in this row, which is a 1. And I do the same trick. Namely, I block out the column and the row that contains 1. And if I do that, you'll notice now I still have a 2 by 2 matrix left. You have to sort of push them together now, but you can still see it's 3, 4, 1, 2. I can take the determinant of that, and I can multiply it by 1. And then what I'll do, since I see a negative sign here, is I put a negative in front of that. So I take the previous number I got and subtract this, because that's what the sign chart says. And then finally, I go to this last element, and I do the same procedure. I block out the row and the column that contains it. I see a little 2 by 2 matrix left. I can compute its determinant, take its determinant, multiply it by this, and then I, in this case, add it. So in fact, the procedure is one where you sort of take a number and multiply it by the determinant of what's left over. And then in this case, I would subtract, because the signs alternate, minus, and take that number and multiply it by the determinant you get of what's left over. And then finally, I add to it this number times the determinant that's left over if you block that out. So let's try that and actually see what you would get. So in this case, the determinant, let me call this matrix, for example, A, just to give it a name. So then the determinant of A would equal what? Well, the first thing I do is I'll expand around this row. So I say, okay, it's going to be 2 times, so it's going to equal 2 times, there's the 2. And now I have to take the determinant of the 2 by 2 matrix I get by getting rid of the column and the row that contains 2. I just block them out. A little 2 by 2 matrix there. What's its determinant? It's negative 2 minus 4. Because remember, it's negative 2 minus 4. So negative 2 minus 4 is negative 6. Then on my sign chart, I see a negative sign, which means the next term is going to be subtracted. So you alternate. You add, you subtract, you add, and so forth. So now I subtract, and then I do the same thing. I expand around that middle element, which means I take 1, and I multiply it by the determinant of what I get if I remove the row and the column that contains 1. I remove that t, and you can see a 2 by 2 matrix here. And what's its determinant? 3 times 2, which is 6, minus 4 times 1, which is 4. So 6 minus 4 is just 2. So I put a 2 there. And I'm subtracting because the signs alternate. The way I combine them alternate. And then finally, I take, and this is sort of a fun one, I expand around this 0 point, which means I get rid of the row and the column that contains 0, and I take 0 times the determinant of this. But that's going to be easy, because no matter what the determinant is, since I'm multiplying by 0, it's going to be 0. So you see, actually expanding around 0 is really neat. And I add, so I have a plus 0. And I don't have to go any further, but just to show you what I would do, I'd say 3 times 1, which is 3. And this is a negative 1, so I have 3 minus negative 1 gives me 4. Doesn't matter, but I'm just trying to show you how I take the determinant of this. And so therefore, the determinant of the whole matrix is going to be negative 12 minus 2, which equals negative 14. So the determinant of this is negative 14. And I found it by just expanding along this particular row. Now, in fact, you could have expanded along this row if you wanted to, the exact same way. Take 3 and multiply it by the determinant you get by doing that. But that's a negative sign there, so you've got to now realize that you start by subtracting. The next thing is a positive, so you take negative 1, and then you crisscross that out. And can you see the matrix there? It's 2, 0, 1, 2. You take the determinant and add that, and then you can expand around the 4, but you've got to subtract it because the sign is here. 4 times, and then what you get here, which would be 2, 1, 1, 1. So you can expand around on any row. In fact, you can even expand around any column you want. You just have to keep in track of the sign chart, which just tells you how to add and subtract the numbers together in order to find the determinant. And this also works for 4 by 4s. For 4 by 4s, you can do the same thing. But then, of course, when you start to block things off, what you're left with is a 3 by 3. So that requires all the 3 by 3 methods. So you can see it gets harder and harder. But now you can see how to find the determinant of anything at all. Now, the thing I want to tell you about next is why should I care about finding determinants? I'm going to show you a really cool little, just fun application just for us up next to show you that, in fact, the determinant actually is pretty cool. And then later we'll look at some real serious applications of the determinant. Until then, just try to work through these examples and remember what you're doing. You're taking it, when you're expanding it around a particular row, you take the element here with the appropriate sign and multiply it by the determinant of the matrix that remains after you get rid of column and row. Column and row, column and row. Take determinants, add, subtract them. You got it made. Enjoy.